Hello class, I'm going to exemplify maybe a couple or three problems from the sections 3J, exercise 3J, and exercise 3K. So for this one, for the number one, it says sketch the parent quadratic, which is this one, and the graph of y equals g of x, which is each of these four functions, on the same axis. Then write down the coordinates of the vertex and the equation of the axis of symmetry for the graph of G. So let's see. This is my set of axes. This is the graph of the parent quadratic, which is the function x squared. There you go. And obviously its vertex is at 0, 0. Then let's go through. I'm gonna do this one, and this one for you. So g of x equals x plus 3 to the square. Okay, this is a simple one. What is this transformation of the parent function? The only transformation is applied in there. You're adding 3 to the input, right? To that input right there. Basically, we go from this to this. That's the only transformation that g of x is doing. And you know that when you add or subtract values to the input, what you will get is a transformation that is a translation in the horizontal axis. Translation in the horizontal axis, when you add a positive number, then the translation is 3 units to the left. So basically, G is going to look 1, 2, 3. It's going to be looking the same as F, but displaced 3 units to the left, according to this transformation right here. That's it. You can corroborate. The first thing you have to do is this, guys. Do it like on your own without any use of any calculator or anything, and then corroborate with the TI or with Desmos. Draw the function g, and you should have this. Okay. So the vertex of g, the vertex of this function is clearly minus 3, 0, right? And the axis of symmetry, the equation of the axis of symmetry, equation of axis of symmetry is the following. What is the axis of symmetry of this yellow function of g? Well, it's this line, the line that goes through x equals minus 3. This one right here. That will be the axis of symmetry. Remember, this number right here is minus 3, right there. And for vertical lines that go through minus 3, the equation is x equals minus 3. Okay, the equation of a vertical line that goes through a point, any given point, is x equals that given point in the x-axis, right? For example, if you had another vertical line going through 6, then the equation of this line would be x equals 6, and so on. Okay, so this is the first one right here. Let me clean this up, and I'll be back with you. So next, letter B, we have g of x equals minus x squared plus 4, which is right here. So this is the parent function in white, which is this one. This is f. And let's see what g is doing. G is a function of transformation on f. This function actually is the transformation of this parent function. And what is it doing? How is this going to look in the end when we draw it in this set of axes? Okay, let's analyze this thing here. So we have a multiplication of minus 1 over here, and we have an addition of 4, right? So we know that there must be the multiplication of by minus 1 is involved in reflections around the x-axis. That's what this means. And the addition of 4 at the end of a function is involved in the translation, I forgot an N in there, upwards. Of 4 units. Now, the thing is this, guys, the confusion that may arise with this one is the following. Which happens first? Is it the reflection around the x-axis or the translation upwards of 4 units? Because you must realize the following. Whether you carry out this one or this one first, the result will not be the same. Okay, so basically the function g, the transformation, depends on the order in which you carry out the transformations, right? Like what I mean is this: when you have a compounded transformation or a combination of transformations, the order in which you take the steps, the transformative steps, do matter. Let me show you what I mean. So suppose you have this function f and you first reflect it around the x-axis. Okay, what will you get? You will get the mirror image of this one on the mirror image on the x-axis, right? Which is gonna look like this, more or less, give or take, right? So we have already reflected f around the x-axis and obtained this. Okay, so there goes one transformation. I'm gonna do this. That's the first transformation. And then subsequently, you translate upwards 4 units. So this one, we are right here, right now, and you're gonna translate it upwards 4 units. So you're gonna end up with this. And this is the second transformation. This is the original f. It underwent this transformation, and then another transformation, which ends up being here. You see what I mean? So this is the end result. This is the end result of first applying the reflection and then the translation upwards of 4 units. This is what you will get in the end, which is not the same as this. Okay, try to remember this, because I will erase it. There you go. Which is not the same as this. I'm gonna do the next in blue. I'm gonna carry out the opposite, the inverse process in blue. So first the translation and then the reflection around the x-axis. So if you take f and you translate it upwards 4 units, you will get this. There you go, more or less, right? So this is the translation of f 4 units upwards. So this is the first transformation. And then if you reflect this around the x-axis, you will get this, more or less. You see, this point becomes this one, this point becomes this one, this point becomes this one, and so on. You see, so this is the final result of undertaking this transformation first and this second. And as you can see, the end result is different from the previous one, which was over here. You remember? Okay, so what is the summary of this? What is the lesson to be learned? The order in which you make the transformations do matter. The order does matter. So in here, which one is being carried out first? Is it the reflection or the translation? How do you know? How can you know? You can know in this way. What you do is this. Look. You're going to take the parent function, and then what you do is this. You're going to apply the transformations one by one, little by little, step by step, until you eventually arrive at the transform function, which is g. Okay, so let's do this. Let's first apply the translation. The translation first. So this is the parent function, and I'm going to write this. The first transformation, which I'm going to symbolize by a little 1 here, a sub-index 1. The first transformation is this. I'm going to take the function, and I'm going to add 4 at the end. There you go. I have applied the transformation on this parent function. And then I'm going to apply the reflection on the x-axis. And remember, this is our current function. This is the one we have now. Okay, so I'm going to do this. The second transformation is going to be this. The reflection on the x-axis is achieved by multiplying the function that you want to transform, which is all of this, by -1. So you're going to be multiplying all of this times -1, which is this. And in the end, you get this, minus x squared minus 4. You see? So the end result of first applying the translation and second applying the reflection is this, guys. This is the end result. Minus x squared minus 4, which is not the same as g. You see? So g, this function, should not be understood as a translation first and as a reflection next. It must be understood the other way around. Okay, first, the reflection. Here we go. Take the parent function. Reflect it around the x-axis. I'm going to write it here. Reflect it around the x-axis, and you should get this first transformation, minus x squared, and then translate it 4 units upwards. You take this, and you should add plus 4 to the whole function. This is the whole function, and then just add plus 4 at the very end. There you go. This is the end result of the process. And as you can see, this is in fact g. So now you know what g is doing. G is first reflecting around the x-axis and then applying the transformation. Basically, g is doing two transformations, one after the other. First this and then this. And now that you know the order, that this should be the first transformation and this is the second transformation done on the parent function, then you're able to draw the graph on this set of axes without using software. Okay, this is just analysis. So the graph of the G should look this way. First, reflect this around the x-axis. So take this and reflect it around the x-axis. There you go. And then apply the translation of 4 units upwards. So 1, 2, 3, 4. This vertex will go up 4 units and you will have this. This is the end result. This is the end result. This should be the sketch of G, and you can corroborate or confirm in Desmos. After doing this analysis, you should be able to do this analysis completely on your own. Then you can confirm that in fact this function is going to look like this. All right. And now it's very easy to get the coordinates of the vertex. The vertex is right here. It's translated 4 units with respect to this one. So we know that the vertex, I'm going to write it in here. The vertex should have the next coordinates 0, 4. And it's also very easy to see that the axis of symmetry of this function g is the same as the y-axis, right? And so the axis of symmetry, I'm just going to write this, should be x equals 0. So there you go. These are the answers. This is the sketch. These are the coordinates of the vertex. And this is the coordinate of the axis of symmetry. And that finishes this one. Now what about D? What about D? So you have, once again, you have the parent function, which is the quadratic function in its simplest form. There you go. And the function g in the letter D is like this. G of x equals 2 times x minus 4 to the square minus 3. So we can see readily that there are three transformations here, three types of transformations. This one, what will this do? This is what is this? A stretch, a vertical stretch, because the constant is greater than 1. Okay, the constant by which we're multiplying the function is greater than 1. So this is a vertical stretch. This is a horizontal translation of 4 units to the right. And this involves a vertical translation of 3 units downwards. Okay, so we have this transformation has to be performed on this function, and this one too, and this one too. Three types of transformations. Once again, the question is which one goes first, because depending on the order in which you apply these transformations, you will get different graphs at the end, guys. The order does matter. It's not the same applying this first, this second, and this third than maybe this first, this second, and this third, or any other combination. It's not the same. It's not the same. So how do you know? Okay, what you do is this: you take the parent function, and then you try to arrive from the parent function to this one by applying the respective transformations. Okay, so the first transformation should be this one right here. Okay, the horizontal translation. There you go. Okay, this step achieves the horizontal transformation of 4 units to the right. There you go. And then the second transformation should be the vertical stretch. So you take all of this and you multiply by 2. There you go. And finally, the third transformation should be the vertical translation of 3 units downwards. Okay, so basically you take all of this is the current function, and then you at the very end subtract 3 units. Okay, as you can see, if we follow these steps one after the other, we reach this one. Now I'm gonna do it wrong for you to compare. This is the right order. Okay, it's first the horizontal translation, second the vertical stretch, and finally the vertical translation, like that. Okay, now let me do it wrong for you so that you can actually see an improper way to do this. If you take the parent function, let me put it in here, and the first thing you say is like, okay, how can I reach from here to here? And if you go like this, well, first I'm going to apply the this one, the vertical translation. This one, the subtraction of 3 to this. Okay, let me do it. So you take the function as it was, and then you apply the vertical translation of 3 units downwards, and you get all of this. Okay, so first I apply the vertical translation. Then I'm going to apply the horizontal translation. So here we go. What do? You subtract 4 units to the input, which is this one. And at the very end, the vertical stretch. So you take all of this function, all of it, and you multiply by 2. So here it goes, 2 that multiplies all of this, all of the function. Like so. And what you get in the end, if after you simplify, is 2 times x minus 4 to the square minus 6. Can you see this? Okay, which is not the same as this. It's not the same as the result. Can you see? It's not the same. So different transformations in different orders get you different results at the end. Which is the correct one? This one. This is this correct order. Okay, so you have to be able to see from let me raise this. You have to be able to see from looking at the function, at the transform function, looking at this, which transformations are being applied first, and then which second, and then which third, and so on, so that you get all of this at the end and not something incorrect such as this. And it could be a little tricky, okay? You need to practice this thing. Okay, there you go with the problem one.